So for station 2 today, we have graphing linear functions. The goal is, of course, working up to the linear inequalities, but in order to graph those, we need to first maybe review just graphing linear functions. So there's two most common forms that linear functions can be written in. So this slope-intercept form is sometimes the nicest form because in slope-intercept form, we have that m is the slope, which is, I like to say it's the change in y divided by the change in x. And then b is the y-intercept. And we can actually see that algebraically, because if the y-intercept is when x is 0, so if I plugged in a 0 for x, I would have 0 plus b. So obviously b by itself is my y-intercept. So this function is in slope-intercept form, and I know it's in slope-intercept form because y is by itself, and there's no parentheses or anything on the right side. It's expanded out. So that's a helpful thing to recognize. Slope-intercept form requires that y is by itself, and no, I think if you just say no parentheses, I didn't spell parentheses right, but I'm okay with it. Okay, so yeah, this is in slope-intercept form because y is by itself. I don't have any parentheses on the other side of the equation. So I just have a number times x and then plus or minus another number. So because we only need to know 2 points to graph a line. So that's also something that we should write down. Line need 2 points, and only 2 points. And conveniently, the y-intercept is just right there. So I know that that's 0, 4. So my y-intercept is 4. And then I have lots of options for getting another point. I could just, one option is I could just plug in 1 for x and then see what point I get and then graph that, or plug in 5 for x and see what y I get and graph that point. Most often, because we know the slope tells us that, so my slope is negative 2/3. So this tells me that if x increases by 3, because it's change in y divided by change in x, y decreases by 2. Decreases because it's negative. So my line is going to be going in the general downward direction. So I'm going to use that to get one more point. So if I just go 3 to the right, then I go 2 down. So 1, 2, 3, 1, 2. So this is 1, 2, 3, and then down 2. Then that's my 2 points. So that's 3, and then that's negative 2. And then, you can keep going and plot more points. So 1, 2, 3, 1, 2. But you don't have to, because it only takes 2 points to draw a line. So that's my line. If you have a ruler, you can just use a ruler and extend the line through the point. So there's my linear function. Okay, so then if a line is in standard form, so that's when we have something times x plus something times y equals some other number. This could also be a minus, or it could be something y. So it could be ax minus by like it is on this problem, or by minus ax. Any of those are standard forms. So with standard form, now there's more space here, you'll notice, because you have two options here. One is we can convert it to slope-intercept form. So we'll try that first. So slope-intercept form means that I need to get y by itself. So I have 4x minus 3y equals 15. So my goal is to get y by itself. So I want this by itself. So I'm going to want this isolated. I want 1y. So I'm going to move the other thing to the other side. So I have to be careful because this is still negative 3y. And now I have 15 minus 4x. Now the order doesn't matter here when you subtract. So, well, it does matter, but as long as I keep the negative on the 4x, then these are the same thing. Subtracting 4x from 15 is the same as adding 15 to negative 4x. Okay, and then I divide by negative 3 because I want to get 1y by itself. And when you divide by a number, you can, division also, we can use the distributive property. So this is negative 4 divided by negative 3 plus negative 4x divided by negative 3 plus 15 divided by negative 3. So negative 4 divided by negative 3. So I know sometimes we like decimals better because we feel better, but fractions are much more helpful with slope. I have a negative divided by a negative, so that's positive 4/3. So I have 4/3 x, and then 15 divided by negative 3 is minus 5. And that's one way to graph this line. So this tells me that my slope is 4/3, and my y-intercept is negative 5. I can do this, and the slope tells me that y goes up by 4 when x goes up by 3. This is change in y divided by change in x. So if x goes up by 3, y goes up by 4. Or if y goes up by 4, x goes up by 3. So 1, 2, 3, 4. 1, 2, 3. And that's one perfectly good way to draw my line. Now I'm going to erase this because I'm going to show you the other way to graph it. So we said, so this is going to be, we're going to say this is using the intercepts method. So the intercepts method, I know that I need 2 points, and then I just connect those 2 points and I have my line. So the 2 easiest points to get, so I'm just going to rewrite this, 4x minus 3y equals 15. The easiest 2 points to get are my x-intercept and y-intercept. So my x-intercept, and this is true for any equation ever, x-intercept means y is 0. So x-intercept, set y equal to 0. So 4x and 3 times 0 is 0. So I have 4x equals 15, and then x equals 15 over 4, and that is 3.75. So this tells me that if y is 0, then x is 3.75. So I have the point 3.750 is on my graph. And I can go graph that. 1, 2, 3.75, about right there. Now the y-intercept we should already know is negative 5 from the first way we did it, but we'll verify it. So to find a y-intercept, I set x equal to 0. And also true for every equation ever, right? Y-intercept means that x is 0. So 4 times 0 is 0, minus 3y equals 15. So negative 3y equals 15. Divide both sides by negative 3, and y equals negative 5. Which, like I said, we already knew that. So my y-intercept is 0, negative 5, and I can go add that point, And now I have 2 points, so I can draw a line. And if you use a ruler here, then you just, you connect those. And one good thing to notice here is, so solving for the intercept doesn't tell me the slope of the line. So if it were some problem where it asked me about slope or like change in y and change in x, then I would want to put it in slope-intercept form. But do notice that if I start from my y-intercept like we were doing, this line still has a slope of 4/3. 2, 3, 4, 1, 2, 3. Yeah, and it hits all those points exactly. All right, so still has that slope of 4/3, even though the intercepts method doesn't find the slope exactly for us. So either of these methods is perfectly good for graphing lines. So you don't have to learn both. Whichever one you like better is the one that you're allowed to use. And I'll make sure to go over both ways when we do inequalities.